Hi, everybody. Can you hear me?
Yes.
Okay, thank you, Anna. All right, let's share the screen here. All right, can you see my screen?
No,
Yes.
sir.
No? Is that a no? You can. Okay, thank you.
I can see. Yes.
Oh, good, good. All right. So what I want to do was talk about Module 5 today. And, well, let me ask if there's anybody who has any questions overall first about Module 5. Anything specific that you all want me to look
Yes,
at first?
I have a specific question about chapter 5.
Okay.
When you have two non-metal, right?
Hang on. Let me get this back to screen sharing
Okay.
here. Sorry about that.
It's okay, don't worry.
Okay, sorry. About non-metals.
Yes, when you have two non-metal, you need to use prefixes, right, for this?
You need to use, sorry, the prefixes?
Yeah.
Yeah, that's right.
Prefixes. Okay. So, but for example, when you have aluminum.
Aluminum. Aluminum's a metal.
Exactly. It's a
Aluminum's a
metal.
metal, Anna. So that wouldn't apply to your argument here.
Okay.
So if we look at the periodic table, let me pull this up here. Actually, I'll pull it up through practice test 2. I think we have a periodic table in there. All right, so if you see where my mouse is and my cursor, the non-metals are separated by this step sort of system here, and aluminum is actually on the metal side of that step. So even though it looks like a non-metal, it's actually a metal.
Okay, perfect.
The other
So
thing, of course, is that you've seen aluminum. You
okay,
know
so
what it
at
looks
this
like.
stage, you need to put both name and that's it. And the okay.
That's right. That's right.
Wait a second, I have another. Okay, what happened when you have ammonia? Oh no, yeah, antimonium. So SB.
Okay, if you
And
look
you
at,
have
all right, so let's say you've got ammonium. Ammonium, if you look up here, it's a cations with 1+ charge. And it's actually it is a polyatomic ion. So let me give you an example. Let's say you had ammonium. We'll say ammonium phosphate just for kicks. You see it here on the common polyatomic ion charts at the very top. It's often ignored though, and it's NH4 plus is what that looks like. And then phosphate, if we look down here, you'll see that it's PO43 minus. So then you're asking the question, well, what do we need to do to make both of these balance? And it would be NH4 3 PO4. Because we need 3+ charges to balance out the phosphate.
okay.
Now what you might be wondering there is the PO4. How many PO4s are there? So I'll ask that of each of you. How many PO4s do you see?
One.
It's just one, that's right. If you had more than one, it would have been in parentheses and there'd be a number on the outside. So if you just see a polyatomic ion like this by itself, it means there's only one of them. But in this instance, there was only one NH4 plus when we started, but now we've got 3 of them. That's why there's the 3 in parentheses on the outside.
Okay. I think one of my practice, I see SB in the with the sulfate. I don't know if I'm wrong, but I think I see this one. So I have SB and S, right? So if I see anti-ammonia have 3 negative and the S have 2 negative, right?
I'm not sure what you're asking about here. Can you be more clear?
I think, I don't know, remember because I don't have it here, but I think I have one exercise and I have anti-ammonia. And
Oh,
anti-ammonia.
antimony. Okay,
Yes,
antimony. All right.
exactly.
Okay, antimony.
And I have sulfur.
Okay. Now it depends on it. Now you're talking about a. Are you talking about a formula here? Are you looking for the name or the other way around?
No, I'm looking here for the name about this one element.
Okay. All right. So
Yes.
you're starting off with the formula, right?
Yes.
So there's really only two possibilities for this. If you've got antimony and sulfur, it would be Sb2S3, which would be,
Exactly.
or the other one could be Sb2S5. But we'll look at both of those. Oops. All right. So we'll look at Sb2S3 first. And if I drew this as a picture, and I always like to do this when I'm trying to figure these out, I know that sulfur has a -2 charge. And the reason I know that is because of where it is in the periodic table. And you can see it's here in this grouping, that's group 6. So you could, if you want to, you can imagine it 1, 2, 3, 4, 5, 6. That means it needs 2 electrons to get to its octet, so it must be S2 negative. So if that's the case, then each of those is going to be worth -2, and the total charge is going to be -6. So what we need there is a charge of +6 on this entire thing, on the SB and the SB, which means each of them is going to have a 3+ charge, which means the name of this is going to be antimony 3 sulfide.
Okay.
So what's your, actually, you look concerned. I can see your face here. So I can see you're looking a little
I've
bit
literally
perplexed.
been doing this. I like literally called out of work for this. Like, where are you getting that from? Like,
which part?
the antimony. Like,
okay, well, the antimony is the SB.
Is the name, yeah.
Right, it's the name of the metal. Now, you've got to remember, actually, when you're looking at these kinds of problems, they're multiple choice. So you already have the antimony as part of the name. You won't have to figure that out. Right, so if you didn't know that SB was antimony, that's not going to be a fatal problem for you. Okay, because it'll be in the multiple choice. Let me show you. Like this here. You see, if you've got something that's got antimony, I don't see anything here that's got antimony in it, but if you did have something here, see all these names that have antimony in them? So you'd know it was antimony. You with me so far?
so antimony is the stuff in parentheses.
The antimony is the SB here.
The SB is the element.
Yeah, SB is antimony. That's the name of that element.
Professor,
Where you're getting that from?
it's not about where it's from. This is the name in the table, you know. He wants to say SB is antimony. If you look in the periodic table, is the name of this element.
Yeah, the SB here.
Uh-huh.
Yeah, I know the name isn't listed here, but it's called antimony.
I see. And this periodic table, you cannot see the name.
No, but you see,
exactly.
but the issue is, Anna, you don't need the name because it's multiple choice, and you can see the metal name in all of the answers.
Yeah, but she is confused because she don't know where you take antimony, but antimony is the name just for the element SB.
That's right. Yeah.
Yeah. Mm-hmm.
So the elements in the periodic table have
names.
Other names that.
It's not another name.
No. SB is antimony is only known as SB is only known as antimony. It's not known as anything else.
So is that the only one?
For SB?
Mm-hmm.
Yes, it's the
Yes,
only one.
absolutely. It's a unique name, yes. What I'm saying, Ashley, is that you don't have to be concerned about memorizing that.
Okay.
Because it'll be here in the multiple choice, right?
Professor.
Yeah.
So my concern is, okay, when you have a metal and non-metal, you need to put a Roman number, right?
Absolutely. Well, when it's let's put it another way.
But let me tell you something, because I am a little bit I'm sorry. I am a little bit confused when you have, for example, semi-metal. At this case, you have semi-metal because antimonic is a semi-metal, right?
It is, but it's still considered a metal because it's not.
It's being considered the metal. Okay, so
Yeah,
this
even
is
though it is it's called a.
I'm a little bit confused, because I don't know if I need to divide the periodic table in just two metal and non-metal, or I need to be careful when I have some semi-metal and,
No, you don't have to
something
be
like
that
that.
careful. No, because you just have to follow that step business that I showed you here.
Okay, just metal and non-metal, and
Yeah,
that's
just
it.
look at that. Yeah, SB is still a metal.
Yeah. Mm-hmm.
Ashley, I want to go back to you. And I want to see if I can solve this issue here. If you understand with SB2S3, what we're looking for is the name, okay?
Mm-hmm.
And the name is going to be in two parts. It's going to be the metal, which is the SB part, and then you've got the sulfur part as well. That's going to be sulfide.
So when Miss Anna just said metal, non-metal, and I'm looking at this here, I don't know if you can see it. So we're only focused on the non-metals and the metals?
That's right.
Mm-hmm.
So not alky metals, not alkaline earth metals?
No, we're just metals and non-metals, Ashley. That's all you have to be aware of. That's important. It's important that you differentiate between those two groupings.
So I see, is it I see the non-metals, which is the step, which I'm familiar with. Which metals are we referring to? The other metals, the transition metals?
Oh no, just all metals. Anything.
Just all metals.
Yeah, all metals.
Okay.
Okay, so you just really have two groupings there: metals and non-metals. That's it.
Makes sense. Non-metals. Okay, so right. Noble gases isn't really a component then.
Okay, you're okay with now? Are you okay with how I drew that picture with two SBs and three S's?
I mean, from the videos that I watched, the SBs, okay, when you break it down, you have two SBs, so that's why you wrote two SBs, right?
Mm-hmm, mm-hmm.
And then you have three, which you get that based on the number below.
From
and
here,
when there's no number above, that means just one.
Right.
And then S3, you wrote S3 because there was, a 3 right there.
That's right.
And then what we know that it's the S3s were negative because of the group number.
That's right. So yes, 2 minus for sulfur because it's in group 6.
Yes, I have a chart here. And then I'm great there. And then I know that, each side has to balance. So -6 plus 6. Where is SB at?
Don't worry about where SB is, except to say that it's a metal because it's on the metal side.
We're not necessarily worried about.
No, because that's not how you're getting the charge. You're getting the charge because you're getting the charge on the positive side only because you know what the charge on the negative side is.
Okay, I figured that. Okay, because you mentioned something like that in a video. So then I guess I just have to, when it says antimony, you said I get that I should automatically know that on the problem because those are the ones with the ones in parentheses?
Well, they're the ones that are going to be at the front of the name. It's like if you see how it's FeI2 here?
Yeah, Fe is iron, right?
Yes, but let's just say you didn't know that. Let's say you didn't know that.
Okay.
then you'd know by looking at the answers that Fe was iron, right?
Yeah.
Yeah.
Oh, yeah, that's a great point. Yeah, because I mean, they're all iron. So.
Right. Likewise, if you had Sb2S3 here as a problem, all of these would be antimony. All of them.
What is antimony?
Well, it's just the name of
Antimony
Sb.
is SB, exactly.
It's just the name of Sb.
Okay.
Right? I mean, look, all of these, let me pull up another instance of my courses here. Every single element has a unique name. Otherwise, I mean, you know how it gets confusing if you've got two people in the room with the same name. Nobody knows who's calling who, right? That's why it's important. That's why it's important for us to make sure that we understand that every element has its own unique name. And let's see if I've got, well, I'll pull up practice test 1 here, and where I did have that, but I don't include this because I don't believe it's necessary in practice test 2 because of what I was telling you earlier. But you see this? This is the list of elements and names, right?
Yes, sir.
That's all set. You don't have to memorize that though.
I did use it quite a bit. Just because, like when the practice assignment or it has like 100 questions. I use that quite a bit because sometimes it's just like, okay, what's the name? Like.
Right. But I want you to more focus on the charges than the names.
Yeah.
Do you see how Sb is antimony? That's how you know.
Oh my gosh. So this will prove that Google is not always your friend. Okay.
Not always, no.
Because I got a completely different, you know what? I didn't even realize that. Because I was looking this up on Google. That's not what they said. And that's probably why I'm so confused now. All right. Thank you for showing me that. That helps a lot.
Okay. Now I have it in other places as well. It's also in the soft chalk as well for module 1. Okay. There's something like that in there. Okay. So going back to here, are you okay with how I'm getting +3 and +3 on the antimonies, just based on the charge, not based on where it is on the periodic table?
So you're getting the +3 from, no. Oh, wait, because it's +6.
Right.
So each one is, well, the other side has to be -6. So we know that this is +6 just by default. And then if we were to essentially divide that in 2, it would be +3 +3.
Yeah, that's what I like to hear.
Me too. Thank you, Anna, too.
All right.
No, your work is too much for me. You need to have too much information for this chapter.
Yes. These Zooms help them.
All right. So what I would encourage you to do is look on the negative side first, add up all those because we know what those charges are. Then we match that to the positive side, and then we split out the positive to match whatever's there. But often, actually, we only have one element on the positive side anyway, and it just takes on that charge. But when you've got two elements, or 2 of one element, it's going to split apart, and it'll split up the charge among them. So the name then becomes, and this is important too, name is just one of these, antimony 3. And the 3 there is the charge on the antimony.
I understand.
And then sulfide.
Because you flip, you need to balance the first step, At this case, you need to look in the first when he put SB3 plus and S2 negative.
Yeah. So
Professor,
yeah.
I'm sorry.
That's all right.
I need to tell you something because I'm confused. Because for you, when you practice, for you it's really easy because, but for example, it's not obvious for anybody. So this is my confusion in the beginning because I'm looking for the chart when I balance, so 6 plus and -6. But this is not what I need to look at when I put the name. I need to look at for the first.
Well, you need to look for one of each, and that's what the names are all based on. And I mean, I didn't make this up. This is just the way that these are named because they're all based on the name of just one of them. So it's the name of one of the antimonies, which is antimony 3, and then one of the S2 minuses. That's why I've circled one of each here.
Exactly. So
Right.
you need to look at the first,
Yeah.
the first, yeah.
Not all 3 of them. So, when that's why when you're doing that big assignment that's got those 100 problems, you're just focusing on one of each. So if you were looking for the single anion or a single ion, the answers would be Sb3 plus and S2 minus. That would be it. It's not going to be 2 of the Sb3 pluses or 3 of the S2 minuses. So you might be wondering, well, how does that help us if we don't know how many of each there are? Well, it's all predicated on the fact that everything has to balance out. So if you knew that the charge was Sb3 plus and you knew that the charge was S2 minus, then from there you'd be asking the question, well, how many of each do I need to make those charges balance out? And you would need 2 Sb3 pluses to make +6 and 3 S2 minuses to make -6. And that's what all of this is based on, because we are making the assumption that every last one of these compounds we're making is neutral, which means it has equal numbers of positive and negative charges on each side. That's how we know. And that's why we only choose to do one of each and show one of each in those examples.
Okay. Professor, I have another question.
Mm-hmm.
When you use the non-metal and non-metal, right? For example, put
hang
nitrogen.
on. Let's finish off this first, and then I'll answer your question about the 2 non-metals. Okay.
Okay, cool.
All right. So Ashley, are we okay with what I've done here completely?
You said the part you just said that you had to balance out, you said we would need 2 Sb
3 pluses, yeah, and 3 S2 minuses.
Oh, okay, I thought you said 2 S2 minuses and all. No, okay, I'm good. Thank you so much.
Okay, all right. So Anna, we'll take a look at a 2 non-metal problem. You got one in mind?
Yeah, I have. You can put whatever you want. It's just I need to know if both have the prefix in the beginning.
Oh, okay, right. So let's say I'll give you a couple of examples. We'll do. Let's see, SO2, and then we'll do P2O5. Okay, we'll do both of those examples. So the first one, this one doesn't need a prefix because there's only one of them on the sulfur, and it's going to be sulfur dioxide. The 2 is going to be di. Now, you might be wondering about having to memorize those, but you don't, because they're all down here. They're all on this sheet. You see them?
Dr. Musgrave, for the benefit of time and getting like a 2-for-1 deal, could you kind of go, when you're showing this to her, could you kind of show like where you're going on each part of the page?
Yeah, sure.
Like the sulfur dioxide, just for like a 2-for-1.
Okay, all right. So you're okay with the sulfur and the oxygen here?
Mm-hmm, mm-hmm.
All right. So we know the first one's going to be sulfur, and because it's second, it's always going to end in IDE, so it'll be oxide. So sulfur oxide. But the 2 here is the di, and we get that off the prefixes, which you'll have in front of you. You can see it there. Is that okay?
Mm-hmm.
Now, it's not, you might be saying, well, why isn't it monosulfur? Because there's only one of them. And the rule is if the first one only has 1, then we don't put the mono out the front. The reason for that is because most compounds of metals and non-metals actually only have 1 of the first element. So it's kind of redundant to be putting the mono all the time.
So if at this case you have S and you have O, just 1, you will be sulfate monoxide.
SO would be sulfur monoxide.
Oh, okay. So, okay, this is one of confused because in the practice you have one of these in 1919 mono, and I say, oh, this does not make sense. Right, definitely right. Okay, so the first one just is 1. You put the name, just the name. no need to put mono.
That's right.
Okay, cool.
That's right. If there's only one of them, though. But if there's two, you definitely do need the prefix. Like for this one here, this would be diphosphorus. Pentoxide.
Oh, I think we had something like that. That really got me.
Yeah, so do you see the 2 is for the di, right? The di is 2, and the 5 is penta.
Would be 5.
That's right.
Mm-hmm.
You could write pentaoxide if you like, but remember, these are multiple choice, so you have them in front of you. You don't have to, there's no real confusion there. You'll just choose
but it's important you know this one, because in the multiple choice have mono. If you know the rule, you would put mono because you have one.
Right.
Yeah, so.
And then sometimes it says none of these, so it kind of was like.
Oh, I know. It's cruel,
yeah,
isn't it?
It's not like an obvious.
Yeah. You know how much sleep I lose over that?
Well, what can we do to fix your sleep? That is abuse. Oh my God.
All right.
So,
go on.
Go ahead, Anna.
Sorry. No, it's okay. You have some question about this one. It's okay. Go ahead.
So again, I know my personal struggles are with rules and order, and that's just, and rationales. That's just who I am. So sometimes it does hurt me. So whenever we're doing these, we always need to refer back to, basically out of the whole 100 problems throughout that whole time, you need to constantly be referring to some part of the chart. It's just about knowing which part of the chart to refer back to. Do I have that?
Yeah, I'd say that's probably true.
Like, because I would get like a problem, and then I'll go to the chart and I'm like, where is it? Like, and then it's like, you kind of see it in maybe 2 places. And then it's like, I don't know. Well,
why don't we, Anna, do you have an objection to this? Would you mind if we just went through problems?
No, at this case, no.
On this test? What about you, Ashley?
Sir?
Do you mind if I just go through problems off this test?
Oh, no, I would love that. I'm ready.
Okay, let's do it. All right, so question 1, FEI2, we're looking for the name. And as you can see, there's a lot of different names here. It's pretty cruel multiple choice, as you pointed out, Ashley, especially with that none of these in the mix as well. All right, let's go take a look. Let me shorten this out a little bit here. All right. Okay. So if you've got FEI2, the first thing you should probably do is look for if iron is where it is on the periodic table, right? That's what I would do first.
Iron.
And what you're going to have to determine is if it's in group 1, group 2, or if it's aluminum. So I'll say this, and I'll just write this down. Type 1, we'll leave this here for reference, is going to be group 1, group 2, or aluminum. And that's it. That's all you really need to be aware of. And
but all of we're focused on metals and non-metals.
Well, at the present time, we can see that Fe is a metal, right? Mm-hmm. And that's all we need to know right now. But what I'm trying to do is tell you this.
And it's in group 2.
So what we're talking about here are cations. And we know that cations are always out the front. So if you've got something like FeI2, we know the Fe is going to be the cation part and I is going to be the anion part. But this is important, what I've got up here. We got type 1, which are in group 1, group 2, or aluminum, which means this is group 1, that's group 2, and there's aluminum over there. And these have a set charge, so we don't put a Roman numeral in the name. But every other metal, all the other metals on the chart that aren't in those groups will need a Roman numeral because we don't know what the charges are. They're not set. These have set charges. The charges are group 1 is always +1, group 2 is always +2, and aluminum is +3. And that matches their groups.
Yeah, that's a good, I like that. Okay.
And then, it's a simple rule then. All the other metals need a Roman numeral. So
at this case is a little bit confused. This is my question in the beginning.
Yeah.
Because thin, it's blue. L is metal, but it's not this case because have in the group Taiwan. So so this is you're a little bit confused about. Okay.
Yeah, you're okay with that? What I've got so far?
I'm good.
Okay.
Archler.
All right, so let's draw a picture now of the FeI2, which is going to look like this. It's going to look like an Fe with 2 I's on it. We're good with that?
Yep, because there's one Fe and then there's I with the 2, which means there's 2. Mm-hmm.
That's right. So now we look at what charge I has.
It's -1.
And it's -1 because it's in group 7 here. I know it's hard to see, it's under your under you, but anyway, that's group 7. So it's -1 in that group. The way it goes is you've got 0, -1, -2, -3. 0, -1, -2, -3, all across those groups. And it's +1, +2, and then over here to +3. But yeah, I is going to be -1. So we put a negative on each of those. That's going to be -2 total, which means that's +2, which makes the ion +2. So that's the order we do it in, like that. Now understand that because iron was not one of those type 1s, then we have to work to find the charge. But you can't find a charge just by looking at where it is on the periodic table. That doesn't make any sense. I mean, it's not going to tell you it's +2 by looking at it. You have to do this kind of math here to figure it out. So that becomes iron 2 iodide. And note that we used one of these and one of these. And I never say how many iodines there are. I don't have to.
This tip up here, that makes a lot of sense because you kind of know, okay, type 2, all other metals, you know your problem's going to have a Roman numeral. So if we look at the answers, that means it would be iron.
You don't have it. Oh, yeah, no, you don't have it.
It's not
none of these. Mm-hmm.
None of these. My favorite answer.
Oh.
Your favorite answer.
Yeah, that's right. Right.
I know it's too much.
Yeah. Cruel, isn't it?
Yeah, it is.
It's almost like you have to actually know what you're doing to get the right answer.
Oh my gosh. Such a good and bad thing.
All right. Is that okay?
Yeah, I'm okay.
All right, next one. SE205. Now, you can see here that you can sort of see where this is going with all of these
non-metal and non-metal.
Non-metal. But you see, that's the thing. If you look at where it is on the periodic table, you've got Se and you've got O, which is underneath here. I can't scroll down, though, to see it. Let me put this on. I'll see if I can put this on the bottom. There we go. So you got O here and you got Se, and they're both clearly in non-metal. So we need to use that whole thing with the prefixes, and we can see them over here. We've got 2 is di, and then we've got 5 is penta from here. So it would be diselenium pentoxide. because those are both non-metals. And is it there? There he is. He's actually in the list. You can see him here.
Mm-hmm. Okay, so just for my brain. So Se2O5. So first thing we're gonna do is notice that they are not two non-metals.
Mm-hmm.
I'm assuming this problem is getting the name.
Yeah, that's right.
Yeah.
Yeah.
And so when I see that they're two non-metals, I'm gonna use my chart and I'm gonna look at.
Now remember, you won't have access to a paper chart. You'll have to scroll back up and look at this one here, Ashley.
Okay, yeah, I think the first test was like that.
Yeah.
And then, okay, di, and then penta. Okay, all right, cool.
But it's all predicated on knowing that Se and O are both non-metals.
Yes, having that clear picture on your side, which side is metals and non-metals.
All right, let's look at this one here, CRS. So CR and S, and if you look at, again, the periodic table, you see where CR is. And you'll notice it's a metal, but it's not in group 1, 2, or aluminum, right? So automatically we know we need the Roman numeral. And we know that S is -2, which means the total charge is -2. That means the positive charge is +2. And the name would be chromium. Two sulfide. Oops.
I got a little lost there.
Okay, are you okay with the fact that chromium's a metal?
Yes, I have it here, chrome, because it's in the well, mine is pink.
Right, and you understand it's not a group 1 or a group 2 or aluminum, right?
I know it's not group 1 or 2, so we need to have a Roman numeral.
Yep, that's right. Which means we need the charge on the chromium. We know what sulfur is. It's in group 6, so it's -2.
Oh, okay, that's what got me. Okay.
Which means that the chromium has to be +2.
Got it.
So the name there would be chromium 2 sulfide, and you can see it there. It's about the fourth one down.
Yeah.
Yeah, it's there.
What's that, Anna?
You say the name is over there in the question?
Yeah, it's here. It's the fourth one down, this one.
Yeah.
Right.
And specifically the 2, that's based on the charge, right?
Yeah. A very common mistake that I see, especially with students who don't know what they're doing, is they will think that 2 represents how many there are. So they'll look at that and say, there's 2 chromiums, right? Well, that would be certainly a mistake, wouldn't it?
Yes.
Which is why chromium 1 sulfide is put here as a name to annoy people. Because you can see there's only one of them here, but that's not where we get the name, is it?
No.
All right, let's look at this one here, BeSO4. That's a good one, since we've been something a little bit different here. Let me get rid of some of this stuff. Okay, so BeSO4.
So Be is, excuse me.
Let's have a look where it is on the periodic table. It's over here, right? So it is definitely metal. Is it in group 1, group 2, or aluminum?
It's group 2.
It's group 2. That's right. So when I do this, that makes it so much easier. When it's one of those, it's just BeSO4. And we know it's just going to be beryllium. So I don't have to worry about the charge. Beryllium sulfate. And I get the sulfate from the polyatomic ion sheet because I can see that SO4 is sulfate. See how easy it is when you don't have to worry about the charge?
Yes.
Because then I just have to say, oh, yeah, it's beryllium sulfate. That's it. Now, I want you to understand why I don't have to worry about the charge. I think that's crucial here. The reason I don't have to worry about the charge is because everybody in the world knows that beryllium is +2. We're all born with that knowledge. Did you realize that? It's innate. I'm just kidding. But anyway, it's in group 2. It's always +2. So we don't have to put the charge in. That's why it's not beryllium 2 sulfate. Because it's always +2. You see beryllium walking...
on the group number?
Yes, that's right.
Okay.
2, right? And it's always... That's why we don't need the Roman numeral. And I think that's crucial to understand. Once you understand that why they don't need the Roman numeral, then it makes sense why the other ones need a Roman numeral. Because if they're not in one of those groupings, we don't know what charge they are. So we have to get the charge off what we know about the negative side. Anna, what were you going to say?
Yeah, this case for HL, something easy to remember is beryllium is in type 1, right? Because
Yes.
have 2 charge. And the another one element will be polyatomic. So at this case, you don't need to put you need to put the name, and that's it. You don't need to put
the 2 here.
Roman numbers. So this is maybe can help you.
Yeah.
I don't know.
So what do you think, Ashley? Does that make sense?
I heard, and sometimes I just have bad internet. Did I hear you say earlier, it was just kind of been lingering in my head, that this section here is aluminum?
No, aluminum is over here. Do you see it on the screen here?
I can't, but that would be where B, A, L, G, A, I, N,
yes,
and
that's
T.
right. Yeah.
Okay, I thought I heard it you say that, but I know that could have just been
it's just aluminum. The rest of these Ga, In, and Tl, they're actually what we call transition metals. They can have more than one charge. So we do have to include a Roman numeral with those puppies.
Okay. That's what I thought though.
It's only aluminum and group 1 and group 2, as far as you're concerned, that are not going to need a Roman numeral because we know what the charge they carry is always going to be.
Okay.
I mean, if I see B walking down the street, you know, I just look at him. I say, oh yeah, he's +2.
Really?
You know, I know this automatically. You never see BE walking down the street? No.
You're quite gifted. Perhaps you should be doing something else if you knew that when you were born.
All right. Okay, any other questions?
Yeah, Professor, what happens when you have, for example, thin?
Yep.
And
so you say SN.
Yeah, when you have XN
You want
and
to do
oxygen, for example.
SNO2. All right, we'll do that one. All right. So you look at the periodic table, and we can see that SN is a metal.
Will be for positive, positive or negative.
Right. It's going to be, and it's first, so it has to be positive. So it's a metal, and we can see it's not in group 1, group 2, or aluminum. Right?
Yes.
So it needs a Roman numeral.
Okay. So in this case, okay.
So here's what we're going to do. Let's draw a picture. If we need a Roman numeral, we have to draw a picture. So what's the charge on O, Anna?
Is an O is -2.
Okay, and you've got 2 of those. All right. What's the total negative charge?
Would be 4 negative.
-4. What's the total positive charge?
Would be 4 positive.
Okay. What's charge on tin?
Tin will be 4 plus because you have 1.
Oh, you're on a roll here. And the name.
Okay, the name here will be, okay, so here will be tin 4, yes, tin 4 oxidant.
Oxide.
That's oxide, I'm sorry. Sorry for my accent.
That's all right. But if it's one of these, it'll always end in IDE. If it's off the
Okay.
periodic table, it'll always end in IDE, the second element.
Professor,
Yeah.
in that, for example, you have germanium, I don't know, germanium,
Germanium, this one here.
yeah,
Yeah.
And that you have nitrogen.
Okay. So if it was GEN, is that what you're saying?
Yes.
Yeah, that's okay. We can do that.
You need
right.
you need to Roman numbers of this guy, or you don't need
You
it?
would, yes, because
Okay.
because germanium is a metal, but it's not one of those type 1s that we talked about, the group 1, group 2, or alumina.
Yeah.
Yeah, so that would be, well, N is 3 minus, so GE must be 3 plus, so it'd be
Yes.
germanium.
Germanium 3.
3, that's right. Nitride.
Okay. Okay, so when the element is in the group 4, plus and negative, so you need Roman numbers.
Yeah.
Okay, all the time.
Yeah, yeah. So tin,
Okay.
lead, yeah, it's the same deal. But you know they're metals. You've seen them. You've seen what lead looks like. You've seen what tin looks like. You know they're
Yeah,
metals.
because it's a little bit confused because, you know, when you divide the table in the metal and non-metal, you
I
know,
know, yeah.
this line is like, oh, this is a knife. You know, it's a
Yeah.
little bit confused, but understand. Thank you. Cool.
Okay, fair enough. All right, let's take a look at the next one here.
Dr. Mustard, I'm sorry that
I'm sorry, Ashley?
I just got really lost on that one.
Of the SNO2?
Yes.
Yeah, okay. So what, okay, what issue did you have there?
So SNO2, the charge is, hold on. The charge is -2 because of its place on the periodic table.
For each oxygen, yeah.
So then that's the first thing you do is look at to see what your charge is. Then -4 + 4 + 4.
Yeah, always.
Help me get the name again.
Okay. Yeah, but it always goes like this. So then we've got tin, which is for SN. But again, if I know it's not here, but you'd know it was SN was tin because it would be listed as all throughout the multiple choice, Ashley.
Okay, so kind of like that.
Remember?
Yeah.
Yeah,
okay.
that's how you'd know. But what about the 4? Are you okay with the 4?
Yes.
Yeah. So yeah, you don't. I think you're afraid of something you don't need to be afraid of with the names. I know you're scared because you're saying, well, I don't know what SN is, right? Well, you don't need to. It'll be listed there in the multiple choice, so you'll be okay.
Good point. Okay, you brought me back. Thank you.
Yeah.
So and then the oxide comes from.
Well, the oxygen, right?
Oxygen. Wait. Oh, I wrote that wrong. I'm sorry. I don't know. I put this GE too close. Sorry. Never mind.
Okay, so oxide, and remember that if it's a polyatomic ion like this, you'll just take the name directly off the polyatomic ion sheet. You don't change any of those. Those are what they are. But if it comes off here, then you always add the IDE.
Okay, got you.
All right. Any other questions about that? Okay, let's look at this one. Selenium trioxide. So I look for Se.
Okay.
And O, and I see they're both non-metals.
Non-metals.
Now we're given, and again, if you were worried about figuring out what Se was, hang on, you can see it's here. What selenium is, you can see it's Se. So that's how you know where to look for it on the periodic table. And you got trioxide, so you know it's selenium and oxygen. So then it would just be 1 Se and then 3 Os. So it'd be SeO3 would be the answer, which happens to be listed there, third one down.
And tri is from?
The three of them.
The three.
Remember, Ashley, you got it up here.
Professor, when you have the name, you need to identify the formula.
Yeah.
Just you need to put, you don't need to balance just you need to put what you see, right?
Right. If it's two non-metals, yeah, Anna. Yeah, if it's two non-metals, yes. See, that's the thing. The reason for that, there's a good reason for why that is. It's because these compounds, when they bond together together in a covalent fashion, which means they share electrons. Whereas these guys over here usually give and take electrons. So this will give and this will take, and we end up with ionic bonds because we have different charges. And those charges need to balance. But in this case, we're sharing electrons. So we're not really looking at charge balance at all when we're dealing with two nonmetals bonding together.
Okay.
So that's the deeper reasoning for that.
I remember you saying that in I think like module 1 or something like that.
Right, that's right. So if we've got oxygen monofluoride, so we know it's going to be 1O and 1F. So the answer would be OF, which I don't think is listed there.
Mm-hmm.
And again, we know we're dealing with two nonmetals because we got here and here. But we also know that because we've got it's a bit of a giveaway here as well. Notice how we have a prefix here. That's it's a big giveaway that it's two nonmetals as well. And it's just O and F, 1O, 1F. Any questions about that one?
No, I think this is clear.
Okay. Let's look at this one, beryllium perchlorate. So this is why it's important here to know what we knew earlier about those charges. And if we're looking for beryllium perchlorate, it's going to be important for us to know what the charge on beryllium is. So it's Be and then ClO4 minus, but we need to know what the charge on Be is. So I go back up to you notice here also, this is really important too. Notice here how there's, well, actually this doesn't really help. Well, hang on, where are we? In the name, notice how there's no Roman numeral? This is really important. So what's that tell you? You say, well, there's two options here. Either Dr. Musgrave has made a mistake or we don't need the charge for some reason. And why don't we need the charge, Ashley? Tell me why we don't need the charge on Be.
Because this is a metal, two,
1 or 2 or aluminum.
Remember what I said, if ever I see Be walking down the street, I always know he's 2+ because he's in.
Then you're very smart because you were born.
No. It's because I was born with that knowledge. That's all. It was innate. So beryllium perchlorate. So we go over here and I say, okay, Be2+. Then I ask myself this question. It's an important question. I ask myself, how many of each do I need to make these charges balance out? Because at the present time, I've got 1 2+ and I've got 1 minus. That's not going to balance. So what am I going to need to do here? How many of each do I need to make this balance out?
You need to put it in parentheses.
Okay, but how many do I need?
You need to put 2.
Right, so it will look like this. BeClO4, and I need 2 of them. So what you can do to check on that, you can draw a picture and make sure it works. And that works. But remember what we started with. We started with this. That's what we started with. So 2+ and 1 minus, and that's how we know what we need there. And here he is here. Here's the answer right here. the most important point there is how to get from the Be2 plus and ClO4 minus to that formula. So Ashley, what questions do you have about that? You still look concerned.
Oh, I'm just more of a thinker. You know, I spend a lot of time like watching your videos and trying to find trends, because I do think, you know, ultimately it's kind of like a trend. You know, you have to know the trend of the different type of problems. So I just
think
to think.
Actually, you can, but it is possible though to try and put too much into it. You know, I want you to try and keep it as simple as possible. I think the most important rule that you need to be aware of is this type 1, type 2 business where you're trying to figure out if it needs a Roman numeral or not. And then understanding why something needs a Roman numeral, why it doesn't. And
I also think I'm going to stop using, I just realized that maybe this colorful chart that was available early on in the semester probably isn't my friend.
It probably isn't.
Yeah, with that table is better.
Yeah, I was like kind of looking at it and I spent like a lot of time looking at it.
Yeah.
Okay. All right. So, Anna, are you okay with the beryllium chlorate here?
Yeah, I'm good with this one.
What about you, Ashley? Are you okay with the? You are? Okay, good. It's good. All right, let's look at the next one. Copper 1 sulfate. Look at this. See how it's got the Roman numeral here?
Yes.
Yeah. See, this makes it real easy. You just say to yourself, oh yeah, copper 1. Oh yeah. I'd be excited to see this question. So what I would do is I'd say I'd say copper 1 sulfide. That's what we're given. And it's going to be Cu plus, and the 1 comes from the 1 tells you it's Cu plus, and the sulfur is -2. And we know that again because sulfur is in group 6. So -1, -2. So we know it's -2. All right, Ashley, I'm going to put you in the hot seat here.
Can you go back down real quick to that problem?
Yeah, I am.
Oh, I did. Okay. So I was right. So again, you said not to think too much. They're all say CU.
Yes, that's right.
So at least you know that.
Yeah, that's right. If you don't know that copper is Cu, you'll figure it out pretty quick.
Okay, and then you know it's 1. Because it says 1. And okay, and then sulfide, you could just look for S, which is here.
-2.
-2.
And what would the compound look like then? Remember, the question you're asking is how many of each do we need to make it balance?
We need 1.
No, over there you need to put 2. So you put copper 2 sulfate.
Why 2?
Because
you know what, actually something easy at this case. So you know at this case you have a copper 1, right? So this would be positive because it's a metal. And that S will be 2 negative because you can see in the table, right? So cross the numbers. So
no, Anna, I'm not teaching that. If you want to do it that way, that's fine. I would rather just say.
Okay, so you can put Q will be 1 and S will be
-2.
1, yeah. So over there you have 2 minus, and over in the for you balance you need to put 2 positive. So yeah, this is the case.
So that's what it has to look like.
Exactly.
Ashley.
Oh, well, so taking it back to like maybe elementary school math, is it also the thought process that in order to get to a balanced
you need to balance the equation.
Okay.
Yeah, the positives and the negatives always have to match.
Okay.
On each side. Because all of these are always assumed to be neutral compounds, meaning that the pluses and minuses always have to balance out.
Which essentially you have to get to 0.
Yes, exactly.
Okay.
Yeah. I think we just had a breakthrough here, Ashley.
I'm telling you.
I think we just had a breakthrough. I like it. I like it a lot.
I mean, Anna's in my other class for lab, and it's definitely.
Believe me, Kinga's killing me too. Oh my goodness.
All right.
Yeah. So yeah, that's okay. Cool. I got you.
All
I
right.
think we are the annoying student all the time ask question.
That's
Hey,
right.
I
Because
mean,
the chemistry is not like obviously. It's not always like oh, this is obvious. No, it's not. For me, it's
yeah,
not.
like anatomy is kind of like, oh, yeah,
Exactly. Yeah.
just gotta get it. So
All right.
this one
So
is the
this
acid
one, it's
one.
an acid, right? Now, if it's acid, then the cation is always automatically H plus. And
Yes.
then we've got this hydrobromic here. Now, the hydro out the front tells you that it's a single element anion. And you know it's going to be Br minus. See, if it wasn't hydro, then we'd know it was bromate. But since it's hydro out the front, then we know it comes off the periodic table. That's a rule, unfortunately. It's a rule you just have to know.
So, Professor,
sorry. One more time.
Because it's got hydro out the front, then it comes off the periodic table.
Yes, okay.
And not the polyatomic ion sheet. If it was bromic, let's do bromic acid. So that would be HBr, right? Sorry about that. Okay, but let's say it was let's say it was bromic acid, right? So that's hydrobromic. So just for comparison's sake, I'll show you. Now we get the acid tells us it's H plus at the front, and the hydrobromic is Br minus. But let's say it was bromic. It's still H plus at the front, but the bromic here is going to come off the polyatomic ion sheet, and it will actually be bromate. And there it is there. And the rule there is ic goes to 8, and us goes to ite. And I had a little mnemonic for this. It was icky, so I ate it, and lighthouse was the mnemonic there. To remember that.
So I ate it.
Yeah, it was icky, so I ate it. Yeah.
Oh, okay. I can get down with that.
So that would be HBrO3. But what I want you to realize here, and this is the most important thing, the hydro out the front tells you that it's on the periodic table. And whereas if there's no hydro out the front, then you must be looking on the polyatomic ion sheet.
Okay. That's a good rule to kind of...
But I'll say this, just between you, me, and everybody else who watches this, I hate this hydro thing out the front. I think it's the stupidest thing that anybody ever came up with in order to distinguish acids. I think it's idiotic. God, I couldn't think of a worse thing to put out the front.
You know, I'm a nurse, so I was kind of like, I guess sometimes we try to link things together, and I was kind of wondering about that.
I think it's silly. I think somebody should. Yeah. Okay. Somebody should come up with something different, something more understandable. But it is what it is, and I just gotta deal with it.
Okay.
All right, let's have a look here. Next one. Okay, so this is the reverse here again. HBr, and you can see it's a single element. So you look at it, you say HBr, and you say, oh, okay, that's going to be H plus and Br minus. So it would be hydrobromic acid. And again, because it's a single element, it's going to have the hydro at the front.
I think I do struggle with how you do that so fast, because I'm barely looking at my sheet and you're already writing. So with HBr, you look at that, it's an acid. So when when it starts with an acid, it's H plus.
That's right.
So then,
but the Br is bromine. I know that too. But again, you can see it off the you can see it in the answers that it's going to be bromine. But it's going to be hydrobromic acid. It's going to have the hydro out the front.
Oh, okay. Yeah, that's kind of like one of those things too. Like if you know what you're doing, you know what you're doing, because then really in factuality, there's only one that says hydro.
That's right. Or has hydro out the front of the name, yeah.
Professor?
Yeah.
I have a question. If, for example, in this case, you will have one element have a 2, 3, you can combine with the prefix and, for example, mono, the travel, no, or you cannot. And the
No,
acid.
not with these, because it
Okay.
says, because specifically up the top is HBr acid, so you know it's an acid. So you're not going to name it as 2 nonmetals.
Okay, so you cannot put prefix in this case.
No.
When you have acid.
No.
Okay, awesome.
Because it specifically says acid next to it.
Okay.
All right. So did you guys want to do, we can re-roll this. We can do another, I think the next ones are going to be related to module 6, if I'm not mistaken. Yeah, these are all module 6 questions. All right, so what I'll do is I'll exit the preview here. We'll re-roll and we'll do some more questions here. Hang on, get out of here.
No, it's my birthday. I don't work today. I'll be done in a minute. I'll call her back.
Okay, so let's look at this one here. Question 1. So that's 2 nonmetals, Te and O. And you can see Te and O over here. And then that's why we know we need to use the prefixes. So that'd be ditellurium pentoxide. You guys okay with that, both of you?
Yeah, no. I'm okay.
Okay. Sorry, Anna?
It's okay. Explain here.
Okay.
I'm okay.
Ashley, you're right? No. Okay. So we got Te and O, and we got 2 of those and 5 of those. So we just go to the prefixes here. Di for 2 and 5 for penta.
And that's because they're compounds, right?
Well, it's because it's 2 nonmetals.
Both is not nonmetal, exactly.
Oh, okay.
See, Te and O, both on the nonmetal side.
Actually, at this case, with the colored periodic table, it's a little bit confused because this element, this element is green. So it's like, it's metal or not metal? Because if you say green, it's semi-metal.
Well,
but this is not making difference.
I wouldn't use that one that's got the colors on it.
Yeah, and I did pretty much all weekend. So I think that's where I got confused. Thank you.
Okay. So what about this one here, PF5? So you look at, again,
so both is non-metal.
Yeah, 2 nonmetals,
non-metal.
Right? So what would the name be?
So over there will be phosphate and penta. Penta
what?
Pentafluoride.
Fluoride.
Fluoride, I'm sorry.
Yeah, it's important because you see a lot of these answers
with ID.
fluorine, right? And then those are wrong. No, phosphorus pentafluoride, that would be the correct answer there.
I'm sorry for my accent.
No, it's okay. As long as you know.
I cannot deal with the ID in the ending, but yeah.
As long as you know the ending IDE, it's okay. All right. Oh, it's on another one. So you got N2O5. Again, these are both nonmetals. And so you know that it's going to be dinitrogen pentoxide. And I don't see that here. There's none of these. See dinitrogen for the 2 here and the 5 for penta. Again, off here, di, penta. And it's not listed. All right, RB3BO3. Okay. So we know it's going to be rubidium. Do you see that, Ashley? You could know just by looking at the names here that RB is going to be rubidium if you didn't know that.
Yes.
Yeah. So for that one, look where rubidium is, Rb, and you can see that it's in group 1.
Which means it's a metal.
Okay, so Rb is a metal and it's got a +1 charge, but because it's a type 1, you'll notice I've been really tricky here.
Just you need to put the name.
Yeah, we're looking for the name. But here's how, this is a bit of thought process. You look at it and you say, RB is in group 1. There we go. RB is in group 1. So we know the charge is already 1+, which means we know that the name doesn't need a Roman numeral. But the right name isn't there.
You know, okay, so I was saying that to myself. Okay, RB is in group 1, so I know the charge is 1+.
But we don't need a Roman numeral.
Which means you don't need the Roman numeral, which kind of cancels out everything, just kind of the process of elimination kind of cancels out every answer except the 1, 2, 3, 4, the fourth one.
Right. But you know, that's not right because it's got a metal in it, so you can't use the prefixes.
Which is the tri.
Right.
So then it's none of these.
Yeah.
Which means you also need to understand, because that 3, 3 is tri in most situations, but that doesn't
But
apply.
this is not non-metal.
Yeah.
So you don't need to think about this because the prefix just you use it when you have non-metal plus non-metal.
Yeah, it's almost like I'm trying to lead you into a trap, isn't it, with that question? Yeah.
Not nice.
Not nice. Not nice at all.
If this is any indication about CRNA school, it's not very
Yeah. Selenium hexachloride. So selenium and chlorine.
All right, so selenium.
And we look here, we see they're both non-metals.
2 negative, the charge.
Yeah, but we're not interested in the charge here. We're just interested in how many there are. So we've got Se and Sl, and we know that hexa is 6 down here. So selenium hexachloride would simply be SeCl6 would be the answer.
Because hexa is just the number, and you get the number off the chart.
Yeah. So when it's 2 nonmetals, it's actually pretty easy. You're just looking at the number of each.
Yeah.
For this one, beryllium phosphide.
Can I do this one?
Sorry. Yes, absolutely.
All right. So beryllium phosphide. So we're looking for the formula. So then beryllium is a metal.
It is. And what's the formula for beryllium? The element.
Be.
What's the symbol? Be. Yeah, that's right. How do you know that?
Because I was born with that knowledge.
No, not because you were born with that knowledge. Because you.
No, because I just know that one. BE and I just know that's on the chart. I'm just familiar with that one. And then phosphide, which I promise you is my downfall because I can't always remember.
Well, let me give you another tip here, Ashley. If you can't find it on the polyatomic ion sheet, it's definitely on the periodic table.
Wait, so phosphate. At least it's in alphabetical order. Okay, so then it means it would be the P, which is a non-metal.
Right. So you need to know those charges. So what's the charge on the BE on the BE? I almost gave it all.
2 plus and 3 negative.
Are you okay with that, Ashley?
Yes, 2 plus and 3 negative.
Right.
Sorry, guys, I'm slow. I have to think about it.
That's okay.
Actually,
Okay.
this is the group.
So yeah, the group.
Yeah.
So then my answer would be BE2 P3.
No. Let's say we did that. Let's just for kicks. You said B2 P3, right? So let me ask you this: do those charges balance out?
No. Oh wait, it's okay. I gotta think about this.
That's all right.
You have a 2 and a 3, and that no. So then you need.
Let me give you a hint here. If you had this equation, you had to solve, right? Oops. Try again.
You need to get a common denominator.
Yeah. And what would be the common denominator?
6.
6. All right. So that would be how you could handle this. How do you get to 6? How many do you need? How many BEs do you need to get to 6?
You need 3.
If you're doing multiplication, which is what you essentially would do here, you would need 3.
Yep. How many P's would you need to get to
3?
6? No.
No, you need 2.
2. Sorry, 2.
There you go.
Oh, yeah, I'm great at regular. Okay. So, light bulb moment. Okay. So now still focusing on how you would display your answer.
That's it.
It would be the BE. Is the answer not on this page?
It is. No, it's there. There he is.
But how is that?
BE3P2.
Are we? I mean, no, because
Actually, the good thing you need to thinking about this is you need to balance. You know, if you have the big number, usually this happen in the right, just looking in the left how many you need to put for balance. You know, because
so
you know the charge.
Flipping it? Are we flipping?
You can, but he said he know.
Yeah, he did. Yeah, no, you see this? This is what Anna was talking about earlier, actually. But you can take the 2 here, and that becomes the subscript down here, and the 3 becomes the subscript down here.
This is like you have the answer here, and you need to prove if this is true, because you have B 3, but how much is the charge for the B is 2. So 2 plus 2 plus 2 plus 2 is 9, right?
No, 6.
So the 6, sorry. 6, sorry. But yeah, but how many you have in P? 2. And what is the charge for P? Is 3. 3 plus 3, 6. You know?
3 negative.
It's like you can prove.
So just, okay, so with the answer, 1, 2, 3, 4, 5. With the answer number 5 on the test, the BE2P3, if I was to write that out.
We did that over here. That's it here. See how it's here.
So
that doesn't.
But when okay, so the reason, because then we're multiplying. Oh.
But you can see BE3P2 works out. That's it. That's it here, over on this side, actually.
This, honestly, that denominator part, and I know you don't teach the cross method, but obviously we do use Google as a resource. And I did see that, and it kind of made some things click, but I see what you mean. Okay.
Well, I'd prefer, rather than just using a trick, I'd rather see students figure it out by using whatever makes the charges balance. I think that because that's why the cross works, but the cross doesn't work all the time, Ashley.
Exactly. It's not work all the time. This is the point. You need to know exactly. You need to know when you can use it.
It fails sometimes. I'll show you. Can I show you an example where it fails, Ashley?
Please.
Don't be confused.
Right, so
well, it's more. I'm just such a rational
I'm rational too. Believe me, difficult to understand.
Okay, what is
this
the
one.
rule that we're following?
No any rules here.
It's like when you looked at that 1 + 1, 1/2 + 1/3, you just know they need a common denominator. But
so if you had lead-4 sulfate, you know that lead is Pb4+ because of the 4, right? And sulfate is SO4 -2 from the polyatomic iron sheet. Are you okay with the charges there?
yes, I just was finding it on my sheet, but I see it here, SO4 to negative. Okay.
Right. So you can see that the crisscross thing there wouldn't work out, would it? Because you'd have a 4 on the SO4 and a 2 on the lead.
But in this case, you have a polyatomic element.
But if you were just to have 2 of the sulfates, that would balance out to 4+. So that would be the correct answer there.
Did you have another question, Anna?
No, I'm fine.
No? Is that okay, Ashley?
It is.
No,
I guess I want to get to a place where I'm like doing it at it's different when you're doing it with someone, and I just want to get to a place where I can do it on my own.
Oh, I know. And now what I was going to say was my advice to both of you, or actually all of you, if anybody else is going to watch this Zoom session, would be to do this practice test again and again, just those first 10 questions, until you're getting the right answers consistently all the time. That way you'll know that you are doing it correctly.
I can definitely say I appreciate you for that, Dr. Musgrave, because I literally printed it because I work overnight, so I printed it and I did that test over and over and over and over again. Even though it was the same answers, it's about understanding the steps that you were doing, which helps you make sure, like you say, you actually know what you're doing.
But if you do it multiple times with different problems, then that'll be helpful too.
Yes. Thank God for that.
All right.
And you have to be very specific.
That's right. Okay, let's look at this one. Osmium 2 hydrogen sulfate. Now, again, you might not know what osmium is, but you can see it there. It's going to be OS, right?
Yes. So OS.
So there's no real tricks here. So what I would know from that is it's osmium 2, which means it's OS2+. And then I hunt down hydrogen sulfate, and I actually see that is on here in the polyatomic iron sheet. There it is, the hydrogen sulfate, HSO4 negative. Are you with me so far?
Yeah.
Okay, so Anna, Ashley, what would you do to balance that?
The answer over there will be, I will be the answer and I will be the Y. It's OS parentheses HSO4 parentheses 2. Yeah. Because here you have 2 OS, right?
2+ on the OS, yeah.
Yeah, and the hydrogen sulfate, if you look in the table, will be 1 negative, right?
That's right.
But you need 2 of these to balance for the 2. Is this correct?
This is.
Okay, yeah.
That's correct.
Yeah.
Is that okay, Ashley?
It's okay. I'm getting it.
Actually, at this case, you cannot use cross cross.
I don't use it anyway. It
yeah,
just
but
it was
sometimes
just
if
one
you
more
if
rule
you
to
use it
remember.
because yeah, but in the polyatomic you cannot use it because you will be wrong.
Mm. Okay, so tin 4 bromide, so that's SN4 plus. Oops.
So this one would be SN.
And bromide is Br minus. And the question is, how many of those do we need? We need 4 of them.
Mm-hmm.
So we need 4 negatives to balance out that 4 plus.
Yes, because at this case, boron will be 1 negative, right?
Bromine is 1 negative, that's right.
Yeah, so we need 4 of these for the balance of the SN4, yeah.
Yeah, do you see that, Ashley?
Yeah, that one was like so easy, like boom, like they all say. I mean, if you don't know what tin is, you kind of like automatically know it's S. If it is on here, it's SN. Then you know it's 4, so that kind of jumps you to 1 here, and then bromide. I mean, it just happens to be one I know.
Well, again, if it's not on the polyatomic ion sheet, it's on the
periodic chart.
It's on the chart, and you just look for Br, right?
Mm-hmm.
You see it's -1 on the chart.
And then it's 4, and then you have to balance the 4. So yeah, that one was like easy.
Okay. Okay.
We didn't all be.
So this one here, thiocyanic. So that one, see, notice how there's no hydro out the front?
Mm-hmm.
So you know that must come off the polyatomic ion sheet. So you look for thiocyanate. There it is there.
Where do you see that one?
I'll show you in a sec. It's here.
Okay.
Do you see here?
Oh, gosh. Okay. So SCN negative.
That's right. But it's an acid, so it's H plus, H plus SCN negative, which is HSCN. So thiocyanic became thiocyanate. Yeah, so it's this one here.
Yes.
Is that okay, Ashley?
Nope.
Okay. Thiocyanic, right? So we look up here for thiocyanate.
Got that. And then you have your
SCN negative. And then you say, well, it's an acid, right? Because it's thiocyanic acid. So that's where the H plus comes from.
Uh-huh.
So the H plus joins with the SCN negative, we get HSCN.
Oh, okay. I guess I was looking for the little plus, but then it's kind of like a rule. So okay.
Right. Well, no, they cancel out the plus and the negative, right?
Yes. But I guess like I don't know. It's just there, right?
That's right. So H2SO3. Okay, let's diagram that out a little bit. We'll have H plus, SO3, 2 negative. And I look for that on the, again, there's no, notice there's no, well, actually, no, it's a polyatomic ion. SO3 is sulfite. So that becomes sulfurous acid. I know the UR is a bit weird, but sulfurous acid. Again, it's multiple choice, so you know that sulfus isn't right, but sulfurous would be correct, and there it is there. But again, it's a polyatomic ion, so you know there's no hydro out the front, so none of those are right. So it's hydrosulfurous acid. Sorry, it's a sulfurous acid is the answer. Sorry.
Professor Richard, thank you so much.
Oh,
I gotta go, but
no
see you next Monday. Thank you.
Okay, no worries. I'll see you later, Anna. Thanks for coming.
Thank you.
See you tomorrow, Anna.
See you, Ashley.
Okay, I think I'm a lot better than where I was.
Well, the best advice I have for you is just to continually do those first 10 questions until you're getting consistently right answers every single time you take the test.
I will. That's how I was, with your help and nonstop trying and watching videos, I was successful on the first exam.
Mm-hmm.
Especially because you give 2 tries, but I'm good.
All right.
I'll email you if anything, but I'm a lot better. I did email you about one, but my you can ignore it.
Oh, okay.
Because I kind of got my question answered.
Okay, cool. All right, that's good.
Thank you. This means a lot to me. Thank you so much.
Yeah, no problem. No problem. I appreciate you coming. All right. I'll see you next week.
Yes, sir.
All right. Bye-bye.